Good afternoon, everyone. Sorry about Kinela's network. I think she's having difficulties with the network. So I'm going to take over the session. Okay, I would like to please request 2 minutes for other people to join in as well. And then we'll be starting at about 15:05. Just 3 minutes for other audiences to join in. Thank you. Good afternoon once more. Welcome to another session of RSWS 2021. This is our 16th live session. As we all know that on the 30th, we're supposed to have this session, but due to circumstances of the network issues, so we had to move the session to this week. So I would like to thank Dr. Binganidzo Muchara to agree to come forth for us this week. And also, I hope that we will give this session a full attention as we did last. So without any waste of time, I'm just going to go through some housekeeping rules. I'm going to request everyone to please mute themselves to avoid any noise disturbances. And another thing, if there's anyone who has any comment or any questions they would like to ask, they can write that in our chat box and we will attend to them. And another thing, if there's anyone who would like to present their own questions, they can do that only after the session. They can raise their hands and then we will give them the platform to present their own questions after the presentation. Today we have our guest speaker, who is Dr. Binganidzo Muchara. who is a senior lecturer of economics at UNISA and currently serves as a program manager for the postgraduate diploma program at the Graduate School Business of Leadership. Prior to joining the business school, he worked in various capacities in the private sector, research and consulting services in the field of economics, water resource management, and agricultural value chain analysis. Dr. Muchara has also served as a research fellow with the research for a number of projects funded by the Water Research Commission and the USAID, the PEAR, the DAF, etc., and South Africa's Department of Science and Technology. Currently, Dr. Muchara teaches managerial economics at PGD, MBA, and MBL level. Dr. Muchara holds a water security governance to enhance, Dr. Muchara holds a PhD in agricultural economics with a focus in research economics, institutional economics, and water security governance to enhance economic performance. His current research, sorry about that. His current research interest broadly includes the theoretical and applied empirical research in microeconomics, resource economics, value chain analysis, and research governance in selected Southern African countries. Dr. Muchara conducts mostly quantitative research, and he is mentoring a number of master's, doctoral, and postdoctoral candidates within UNISA and other universities. I would like to welcome Dr. Muchara amongst us. Dr. Muchara, you can now take place, or you can now take over. Thank you.
Yeah, thank you very much, Venolia. Thank you very much, colleagues. Let me confirm, can you hear me clearly, Venolia?
Yes, I can hear you clearly.
Thank you very much, and good afternoon, delegates. And thank you, the organizers, for putting this event together. And I want to start by apologizing what happened in the previous session. We couldn't go ahead because of technical glitches. We kept on being kicked out of the system. Hence, we are reconvening today, and we just hope that we'll be able to complete today's session. It has coincided with load shedding, but we just hope that it's not going to affect us. So, without wasting much time, let me introduce myself again. Not as long as. Are you talking, Venolia?
No, it was not me. It was one of the audience, so okay. I muted them.
Okay, thank you. So I am Dr. Muchara, and I'm currently serving as a senior lecturer with UNISA, as Venolia has rightfully introduced. So I'm not going to spend much time on those introductions. I'm going to go straight into the business of the day, and I'm going to present to you quantitative data collection techniques and analysis. So you might have realized that as Venolia was introducing you, I'm more of a social scientist as an agricultural economist. So in terms of the data that I'm going to present and some of the methodologies, if you are from the natural science field, or if you are from a pure mathematical, maybe you might find them a bit weak, but I hope that I'm just going to be able to talk to those universal principles that are required in conducting quantitative data. So my presentation is going to basically look at the types of research data, the types of empirical data, and steps for analyzing data, and then look at a few examples of basic quantitative data. And then I'm going to give a general overview of some of the models that can be used to analyze quantitative data. And I'm going to conclude by giving you the limitations of quantitative data. That's a mistake. I said secondary data. So basically, quantitative data it's a research that combines economics, mathematics, statistics, and to provide numerical values for parameters of relationships. So to measure economic behavior, social perceptions, and some economic phenomenon. So as you might realize that when you apply quantitative data, you are trying to achieve something that is a bit unique that any other type of data might not achieve. You want your data, normally your data is quantitative because it's measurable. So you want to attach a measurement to your data, and you want to be as much precise or closer to reality as possible, though you might still not get there. There are still some errors that you have to plan for. So in terms of quantitative data, therefore, it involves the gathering and measuring of information or variables of interest. And it's established systematic fashion that enables one to answer research questions, test hypotheses, and evaluate outcomes. So by you conducting quantitative research, you are basically saying you have in the first place, you have a research problem. And this research problem, as you specify your hypothesis, you are realizing that the best way to actually come up with viable outcomes is actually to be able to measure some of those hypotheses quantitatively. So you then have to employ quantitative data collection and analysis so that you can be able to measure those research outcomes. So in terms of the quantitative data, it's either the data can either be primary data or it can be secondary data. But the most important part is this data has to be numerical. Whether it's secondary or primary, the data has to be numerical. And that is the main distinctive feature from qualitative data, which can also exist in the form of primary and secondary data. I think this is all basic information for most of the delegates because we deal with these things every day. But for the sake of inclusivity, we don't know. Some could be here for hearing quantitative data for the first time and they want to enter into research. So it's also very important for me to emphasize these differences. And in terms of the quantitative data, what are those types of quantitative data? And what are the sources of quantitative data? We're talking about survey data, population census, health statistics. Currently, we are gathering lots of statistics on COVID. That's quantitative data. How many infections? How many have recovered? How many have been vaccinated? All that is quantitative data. And we also have lots of government statistics, demographics, transport statistics, number of flights, number of passengers, revenues, and all that. All that is quantitative data. And if we don't have mechanisms to gather that data and to analyze that data, it might be wasted data because it won't be applied, it won't be used to inform decision making. The reason why we want to analyze this data or want to collect this data is so that we can be able to use that data for decision making purposes, which is the basic principle why you want to do research. You want to contribute to knowledge, you want to apply the data for decision-making processes. So that's why we need that data. And in terms of the sources, you can have internal data sources. And when I'm talking about internal data sources, I'm talking about those sources that include possibly your internal sales data, your revenue data, your internal expenses as an organization, your cash flows, your marketing data, your customer satisfaction reports that you actually contact to measure whether consumers are really happy with your services. And then we also have external data, which can be collected from outside the research or the researcher's organization. This is data that you can gather from government statistics, or on public platforms for your competitors. Let's say you are a vehicle manufacturing company, or you're doing research in the vehicle sector. You might actually gather data externally from other manufacturers, other competitors. So that qualifies as external data. We can also gather data using journals, tracking journals, coming up with panel data. You can actually gather data, on World Bank data, IMF. So there are so many sources of this data. But for this purpose of today's discussions, I'm not going to spend much time talking about secondary data because I understand on the same platform, there was a colleague who is also, I think, a professor within UNISA who presented about secondary data. So my selection today, I'm going to focus more on the cross-sectional data. because the secondary part was actually covered. And I think it's only fair to be able to expand our horizon in terms of understanding quantitative data. So in terms of the empirical and the types of data, we do have the time series data, which are observations that take place over the different time periods of a period of time, which is purely your daily data, monthly data, annual data. So it can come up as time series data. We also have cross-sectional data. These are the values of one or more variables collected at the same point in time. Let's say you go out there, you administer a questionnaire, a survey, you ask about 1,000 respondents, they give you respondents. So that type of data that you gather from that, it's at a certain point in time that is called cross-sectional data. And then we also have pooled data where we basically combine the time series and the cross-sectional data. And I think you can actually gather that by combining those two, you can actually get a much richer data set by combining time series and cross-sectional data. And we also have panel data sets, and which is pooled data for the same cross-section unit. And we use, normally this data actually covers the behavior of certain units or certain respondents over a period of time without necessarily changing the data collection tool. You are maintaining the survey or the data collection tool over a certain period of time, and then you are monitoring behavior changes over a given time period. And you can actually monitor their consumption patterns over a period of time or over different phases of their lives. And then you can be able then to analyze the data. And then that data is also called panel data. It's actually a very good type of data set as well, because you're monitoring the same respondents or the same research units. But what is important when you are collecting quantitative data and when you want to choose whether my analytical methods really is very important in terms or matches the data that I have, you have to ask yourself whether you have selected, whether the data that you have adequately answers the research question that you have. And the other question that is very important is this method that I'm going to use to collect data really suits my budget? Is it affordable? These are some of the realistic issues that you need to ask yourself when you want to conduct quantitative data. It can be costly to collect quantitative data because of the numbers that you need to interview. And after interviewing those numbers, if you're not very clear of how you are going to analyze that data, you might end up sitting with huge data sets and wasting it because you're not getting much value out of that data. So you must think clearly to say, if you want to analyze the impact of a certain economic policy on the consumers, and you want to ask them on a cross-sectional survey, you want to ask them, make sure you collect the relevant data, all the variables that you require that can make you answer the research questions. And you must be able to choose the best method that is available to actually collect that data. And you must also be able to say, is this method really affordable based on your budget? Because as a researcher, you want to say, I have a certain budget. And in economics, we always talk about constraint, budget constraint. There is scarcity of resources. So you need to want to match all that and make sure it goes back to your original research question. And in terms of the data analysis softwares, we actually have lots of analytical softwares, hundreds of them, but just for the sake of mentioning some, we do have your SPSS, which is, when I did a Google search, I think it was the most popular. I'm not sure why, whether it's the best in terms of analysis or it's just its simplicity and it's being used, it's user-friendly, I'm not sure. And then we also have Stata, which is also very popular, especially among economists. And then we also have statistical analysis system, which is also very popular, especially among natural scientists, your agronomists, your animal scientists. You also have eViews, again, another popular, especially for time series data among economists as well. And then we have the R statistical software. We have the MATLAB. So I'm not a guru for most of these softwares, but I'm just mentioning. And the way you are going to, which software you are going to choose, it purely depends on your capabilities and what you are familiar, what you're comfortable with, your competencies. So you might actually choose some softwares because that those are the software that are at your disposal. Maybe your organization pays for those licenses. So it's not a hard and fast rule to say you have to use this software. You can choose any. There are hundreds of those softwares, or if not thousands, in the market that you can choose from. But for the sake of this presentation, much of my illustration will be coming from mostly the data that I did using SPSS and Stata. So those are the two softwares that I actually applied. So in terms of the data measurement, as a researcher, you must be able to know when you collect your data, what are the different types of measurements that is available. And these different types of measurement, it might look basic that you have nominal data, you have interval data, you have scale data. Why is it so important that you know what type of data that you are dealing with? Because in most cases, this data, the knowledge of the data that you are dealing with actually informs some of the models that you are going to choose when you want to do your data analysis. Some models are applicable on interval data, others are applicable on nominal data. So it's not that you rarely find these models that can cut across all these types of data. So your knowledge of what type of data am I dealing with, it's actually the basic principle that informs the type of models that you are going to choose. So it's very, very important. And I'm not going to spend much time discussing what the attributes of all those variables are. The presentation will be available to you. And I just want to make sure I fly as much as I can so that I can be able to conserve on time. So once you have collected data, I have always found, especially among some of my students, that they go out there with a questionnaire. The first question that they ask themselves, they've brought these 300 questionnaires. How am I going to capture them into Excel? Such a basic principle, they would need really somebody to help to really develop the template to convert the Word document of a questionnaire into a spreadsheet that you can now then actually be able to manipulate quantitatively and put and insert it into a data analysis software. So you can either capture your data in Excel, which is the most popular approach with most researchers because they have easy access to Excel. I also prefer use of Excel instead of using SPSS. Why? Because in most cases, our Excel doesn't expire, so it's always available. So imagine you've captured your data in SPSS and your licenses run out and you can't open that data set. So you'll be in trouble. So if you can capture it in Excel, in most cases, it's compatible with most data analytical softwares. But before you do that, make sure you check properly whether the software that you have that you intend to analyze your data is actually compatible with Excel, and in which format does it take the data. When you capture the data, does it allow gaps on the variables? Let's say if you look at my horizontal axis where you see a participant number, can you see that there's a gap between participant and number? Q1 dot, there's a gap there. So some softwares might not want that gap, and some softwares can actually specify the number of characters to say your variable name cannot exceed 8 characters. Yes, so you must always be able to say, what are those things that are required in my software before you even start capturing? Otherwise, after capturing, you realize you have to redo the data again because it's not compatible. The more you want to import it, then it will be reading error messages. So you want to avoid that. So you normally capture it horizontally where you have your variables. And as you go down from participant on column A, then you are talking of your respondents, where this is a participant number. So I used 1, 2, 3. You can actually use, if you're using certain codes that makes your respondents anonymous, you can use those codes. So, but at times using 1, 2, 3 can actually allow you to trace which questionnaire have you captured and which one hasn't been captured. You can actually number them as you capture. So after that, you then, when you're developing this template here, you need to be able to ask yourself the type of questions that I have. I always find some researchers battling, or some, especially the entry-level ones, you are doing a survey for the first time. There are some questions where a single question represents one variable. And this is an example that is on the first one. The question is, was the content of the course relevant to your job? There you are asking about content and its relevance to your job. So the answer that you get there is actually either yes, to a greater extent, yes, to a little extent, no, not at all, I don't know. So you basically expect one answer. There's no way that one person can answer to say yes to a greater extent and at the same time says, I don't know. So in this case, the question represents a typical one variable. So you basically capture it under one column, maybe under B, relevance of the job. So, but now we have a unique question, which is very, very popular at times in most of the surveys. A question like this: which software have you used in your job? And under such a question, can you see that it's a case of one? The question is one. It will be multiple. Let's say you've used 3 softwares. So in this case, each answer here can now be derived to become a variable, where you are saying SPSS can be a variable on its own. Those that have used SPSS, it becomes a dummy, yes or no. Yes, I've used SPSS, or no. And then those that have used MS Excel, those that have used Stata, those that have used Atlas TI, those that have used NVivo. So as you capture your data, then basically you are saying, within one question, you have created about 5 variables. And these are the variables that you're talking about: SPSS, Excel, Stata. But it is becoming much longer. It now has about 5 or 6 variables on the horizontal axis, yet you only have 2 questions that you have asked. So you might actually have a shorter question, but if it's in a table format, in most cases, that questionnaire can generate multiple variables. So as you design your questionnaire, you must also be cognizant of that. You end up having much longer spreadsheet. And in terms of capturing or importing data, you know, when you capture your data, make sure you actually develop a code book. What do we mean by code book? You must be able to specify what does each numerical value represent. And you must be able to set up your data structure and enter the data. So what I'm trying to say here is, you have captured your data like that format. What does a 1 mean under Q1? What does a 3 mean? What does a 4 mean? What does a 2 mean? So you specify that. If a 1 means SPSS, or if a 1 means, let's say for this question, a 1 means to a greater extent, a 2 means to a little extent, a 3, they have to be specified in your code book. Otherwise, if you don't specify, what it means is, after, when you now do your analysis, remember, you'll be having such a long spreadsheet and you might not be able to tell because you have so many ones across variables. There is a 1 here in variable B. There is a 1 here in variable Q2A. There is a 1 here, but all these ones across variables, they mean different things. So that's the importance of a code book. Make sure your code book is clearly specified. Where you recode the variable, you change the variable name. Make sure you go back to the code book and be able to change it. And then you do the screening of the data, identify missing variables, any omissions, duplications, outliers, and then you can actually combine some of the variables by recoding them. You can combine either by multiplying some of the variables. Let's say you have collected data on quantities and price, and then you can actually come up with a variable called total revenue by just multiplying the price and the quantity. You don't need to ask your respondent that, what's your revenue? Because if he has told you, if you have asked that businessman to say, how much quantities of your mobile cell phones do you sell per month? And he tells you, I sell 50. That's the average. And how much, what is the average price? And he tells you, I'm selling an average, my gadgets are, 3,000 rands. There's no need for you to go back and say, okay, what's your revenue? During your data analysis, you can basically compute that. You can actually capture the quantity, you capture the price, and then you compute your own variable on total revenue, which can now fluctuate among all the respondents. So these are some of the things that actually makes your data collection much easier, because instead of spending time asking a question, he can tell you how much he sold, he can tell you how much price, at how much price. The moment you want to ask revenue, he might start asking for receipts and trying to dig into archives, which might not be necessary because you can compute that, and it can actually cause unnecessary discomfort for them to disclose. So some of these variables can actually be captured. So the same, if you are doing in Excel, you still need to do the code book as well. And by the time you import your data into SPSS or into Stata or whichever software that you are using, then your code book must also be defined in that code book in that software that you are using.
I'm telling you, this is too basic for me.
Yes, and then by so doing now, we move on now to say, what are the types of data that you have? You then have your descriptive statistics and you have your inferential statistics. And when you're talking about the descriptive statistics, these are general. You are basically presenting the layout of your data and what are the attributes, your averages, your means, your frequencies, and all that. But your inferential statistics, this is where now you want to say, what does the data really mean? And then when you want to move on now, then you need to be able to say, these data sets that you have collected, how best can you use them? We normally run descriptive statistics because that is the basis for you to actually identify some of the errors, repetitions, everything that you would have actually, made, some errors that you would make. Let's say you have captured certain outliers wrongly. You can actually pick it up in descriptive statistics to say, here is an outlier. Then you go back to the source document and rectify that. And then you can also be able to pick up some missing values. There are some respondents that did not pick, and that's the purpose as well for you to actually search and remove that. And then in terms of inferential statistics, we basically have lots of inferential statistics that you can go, which range from parametric data and non-parametric tests, your correlations, your t-tests, your ANOVAs, your chi-square, and your regressions. And examples of these questions that require inferential statistics: did the numerous scores for the intervention group improve from the pre-test to post-test? If you have a control group, you have tested, or they've written a test, an exam. Let's say it's an academic situation. They've written a test. After writing a test, then you record the scores. Then you give them tutorials. The first test, they did not have tutorials. The second test, now they have tutorials. Now you want to measure the assessments. How did they perform before and after? Then you need basically inferential statistics to be able to tell the difference between those groups. And then you can also try even to find the differences between, the amount spent studying versus economic scores. So these are some of the examples that you really need some of the inferential statistics. And in terms of selection of data analysis techniques, it goes back again, the type of data, the measurement of the data that you have. But we basically have two broad categories: your parametric and your non-parametric tests. Your parametric test, this is a board of tests that are based on the normal distribution and requires some variation of 4 assumptions. That is the normally distributed, homogeneity, and the homoscedasticity, interval, or independence. While on the other side, we have non-parametric. So it means if the data does not conform to these assumptions here, the 4 assumptions on the left, then most likely it's violating the normality test, it's violating homogeneity assumptions, it's violating all that, and the data is not independent. Then you need to choose alternative non-parametric tests. And then by choosing non-parametric tests, you need to be able now to say, which are those non-parametric tests that talks to this specific data? If it's nominal data, if it's interval data, because the non-parametric tests that you might use for continuous data might actually be different from the ones that you use for categorical. And it's very important for you to be able to tell. So I've given a table here, a summary of those variables that you need to be cognizant about. And then this is the purpose of the data. Let's say you want to run, you want to explore relationships, basically between categorical variables. Most likely you're going to use chi-square. These are basic, tools. And then let's say you want to explore relationship between continuous variables. If you want a technique that measures that, most likely if you use a parametric approach, then you're going to use a bivariate or for partial correlations. But if the data does not conform to some of the normality, these assumptions, you have to choose an alternative for that, which is the Spearman's rule correlation. So these are some of the basic issues that you need to be aware of. Are my assumptions violated? If they are violated, what does it mean? You choose an alternative. So in most of the parametric tests that you have, you also have a non-parametric equivalence that you can actually run depending on the type of data. You want to compare two groups, most likely you're going to use an independent test. But if it doesn't conform to those assumptions that we specified in the previous slide, then you're going to use your Mann-Whitney U test. And in most textbooks, you find it as a capital U. It means Mann-Whitney U test. And then let's say you want to compare one group at 2 times, before and after. You have tested and then after. You might need a paired sample test because these are repeated. You are repeating the same group after an intervention. But if you need the metric, you now have to go to Wilcoxon signed rank test. And then if you want to compare 3 groups, that's where you have to apply the ANOVA, one-way ANOVA, or the equivalence, Kruskal's. So all these, I might spend time, but you will have to read all these on your own. But I wanted to illustrate that you cannot use one methodology or approach to suit everything. You need to be able to choose. And that's the most basic issue with quantitative data. And then in terms of the parametric tests, most of these correlations, they detect linear relationships between 2 scale variables. And I wouldn't want to spend much time on this, but in terms of the interpretation, you must know that your correlation coefficient ranges from -1 to 1, where the -1, it could be showing a negative, it's negatively correlated, and then a positive shows a strong positive correlation on the positive side. That is basically on the interpretation side. And in terms of actually using the usefulness of determining whether the relationship between dosage and outcome. So you can actually be able to check, is there a relationship between teacher attendance at training and learner performance? Let's say you want to see, are those trained teachers really doing better and are they influencing outcome? These are all those examples that you can actually use the correlation. So I want to move a bit with a bit of speed because I'm seeing here the time is also not on my side. But I've given quite a good number of examples that we are going to deal with today so that at least we'll be able to check whether we have done all the required assumptions, we have done all the required techniques that is actually required for us to bring valuable data. So in terms of, I've given an example of a research question that might actually need us to apply a quantitative tool to measure. And the question says, do people with high levels of perceived control of work pressure experience lower levels of perceived stress? Because somebody can say, no, I have stress because the pressure is so much. And there are those that say, I can handle my stress, my pressure, hence my stress levels are low. I can handle it very well. And you want to test that. What method are you going to use to test such a relationship? The first starting point is you want to understand the relation, you want to run the assumptions of the variables that you have collected, how you are going to measure the controlled work pressure and the stress. And then you want to run for the normality scores. How are they measuring the scores? And how you want to measure the linearity. Is there a linear relationship between the two, pressure and stress levels? And you want to measure, you want to check the assumption of homoscedasticity. So when you check all these, you go back to your data analysis. I've used here results from SPSS. So after measuring the results from SPSS here, we did a normality test. These are arbitrary numbers, colleagues. They are not very specific. So after doing a normality test, you can see that the values here are significant. But when you're doing a statistical set, if these values are significant, it means your data is not normally distributed. And then it's confirmed now by histograms as well that you also have to run. The moment you see the histograms, you can tell you that this data is actually normally distributed. So when it's conformed to this normality distribution, then the analytical method that you are going to use to choose basically talks the type of correlation bivariate data that you're going to choose. It has to conform to normality test. And if you look to normality assumption, if you look at the assumptions that we specified when we're comparing parametric and non-parametric, and by it conforming to normality, then the type of correlation that you are going to run there is the Pearson. Yet it's not conformed to normality, and let's say this data was not normally distributed, it's either skewed to the left or to the right, then you are not going to run Pearson. Most likely you are going to run your Spearman's rho correlation. And the circles there, they indicate, the 0.00, it indicates basically your significance levels. And while your R there, it basically measures your correlation. And your interpretation of your R value is basically, I've put a table there at the bottom that actually shows you the range to say if you find your R at a certain scale, then what does it mean? So what does it mean? So in basic terms, when its range is between 0.1 to 0.29, then it's a weak relationship, it's a weak effect. And then from moderate, you get it from to measure the strength of the relationship. You must also be able to measure whether the relationship is statistically significant or not. By statistically significant, I'm referring to the p-values, the 0.000. If it goes beyond statistical significance, then it means there is no relationship. So that is typically an example. So I'm going to emphasize when you interpret your quantitative results to be conformed to, the direction of the relationship, positive or negative, the strength of the relationship, is it weak, is it moderate, is it strong, and then whether the relationship is statistically significant or not, your p-values. So those are basic, and even on your write-up, it means those have to be illustrated. And again, I do have some examples of some t-tests there, and I'm not going to spend much time on those, because I wanted to spend more time in terms of showing some of the complexities that you can actually find in terms of running some regression models. So in terms of the assumptions of the t-test, again, you are going to be able to check the assumptions of the t-test, independent t-test. Make sure any test that you run, what are the assumptions? Does my data conform to those assumptions? So the assumptions of a independent t-test, for example, the dependent variable must be interval or ratio, and independence, it should be there, two distinct groups with distinct participants. So that's one thing that you need to make sure that before you conduct an independent t-test, is my data independent? Normality, it has to conform to normality test, and then homogeneity of variance, it has to conform to that as well. And you have to check the Levene's test, whether that data as well conforms to either parametric or non-parametric test. So when you run all these assumptions, then you can be able to choose the best method that you can be able to use. Sorry for that, my mouse was sticking here. Okay, can I confirm, am I clear?
Yes, you are.
Thank you very much. So basically, those assumptions, once they are met, then you can now go ahead and run your independent sample test. And still, when you do run those, you will then be able, you are comparing for independent sample tests, you are basically comparing the independent, whether there is any significant difference between the means from the group that you are basically comparing. And again, you need to be able to check which shows the mean scores on the other side, all the red circles. And then here, the Levene's test. And I've actually explained here at the bottom to say if the Levene's test is not statistically significant, then the homogeneity of variance assumption has been met. So basically, you have to check as well the significance of that. And if it's not statistically significant, which is the ideal, it means your data is actually normally distributed, and as well. And then you also have your significance levels. In this case, your significance level here is actually not significant. And if the significant is not significant, then it shows you, how does it tell you now that the means from the two groups that have been collected is actually different, or they're significantly different, or they're significantly similar. So basically, those are some of the things that you need to do so that you can be able to actually be able to assess your independent t-test. There is a stage here that I did not indicate, that I did not compute, the calculation of your R values. Then you need to be able to compute it based on your T values and your degrees of freedom, where you are saying your R value it's actually t squared divided by t squared plus your degrees of freedom. So your R values, again, once you get your R value, then you can be able to check on your scale whether there is a weak relationship or there is a moderate or there is a strong relationship. So basically, I'm going to follow a classical 8-step methodology. Let's say you have a hypothesis, you have a problem, a real life problem that you are going to want to test. What is it that you are going to look at? Check your theory of hypothesis first. How is your problem been hypothesized? And what is the mathematical specification of that theory? What does it say in terms of assumptions? And what is the statistical or econometric model that actually specifies the relationship that you want to test? And how then are you going to obtain the data, and what type of data are you going to use? And what estimation are you going to apply, the parameters of the model? And then the next stage now goes to hypothesis testing and forecasting. And then you then apply the results for policy purposes. So I'm going to use a specific data that I'm going to use from one of my journal articles that I published to see how best we can manipulate cross-sectional data. But you realize that I did not just use one approach, one technique in that paper. So there are multiple techniques that we combined to actually make sure the paper or make sure the outcomes are much more, can actually inform decision makers. So on all the regression models, remember when we started, I introduced the parametric, non-parametric, and I covered those basic correlations and all that. And there are also regression models that talks to quantitative data. You have your ordinary least squares, which is the most common and mostly abused as well. Though it is the beauty about it is normally applicable to most data sets. And then you have other logit models, multinomial logit models, linear probability models, probit models, ordered logit models, ordered probit models. So there are so many, and there are so thousands of these models. So your choice also depends on your comfort and depending on the data set that you have. Some models are run better in other softwares than others. So depending on your software that you have, the strength of the model that you want to run in terms of its ability to estimate the data that you have, then you can choose. So in my specific case, I actually took this is one journal article that was published in Water Essay. And on this journal article, we analyze collective action and participation of smallholder farmers in irrigation water management in KwaZulu-Natal. And maybe just to explain, so that when I explain the processes that we did quantitatively, how to analyze this topic, then you can be able to understand, to say, we wanted to understand how does participation of individual members in a group setup actually enhance water management. So collective action here being defined as a group working in groups by individuals to actually achieve a common goal. And the common goal that these farmers wanted was efficiency, improved irrigation water management. And they realized if they don't work together, yet they are sharing water in terms of canals, in terms of water taps, but in this case, it's an irrigation canal that was stretching over 20 kilometers. And there are so many households with almost over 800 farmers who are all producing independently. So you can imagine the dynamics there of them trying to share water, trying to fight over water. One takes water on a certain day that is not allowed. So at the end of the day, we tried to measure how that collective action and the participation in that collective action can be measured quantitatively. Of course, if you ask social scientists, they will tell you no, man, but participation can always be measured better in qualitative terms, which is true. But as quantitative people, we also want to attach a value to that and say, how do I measure participation? If someone who built a canal, did he participate better than someone who just came in and make a vote to say, I'm voting for a chairperson, Muchara is the chairperson? How do we distinguish those? Qualitatively, it's easy. You can just go interview, ask for perceptions, people tell you they are thinking, you code the responses, and then you summarize. And quantitatively, you might want to attach some values that actually you can use to measure such. So in this case, participation, we ranked participation as a scale from 0, which is a farmer who is not involved in any activity in an irrigation scheme, and then to about 4, of a farmer who is highly involved. So these are 5 categories. 0, 1, 2, 3, 4. That's 5 categories. So, and if you are in between, then as you move from 0 to 4, your intensity of participation as well is going up. So I used there with my co-authors, we used quite a good number of techniques. The first technique, we managed to quantify the data descriptively, took all the variables, profiled descriptive statistics. After that, we ran a principal component analysis to reduce the dimensionality of the data. The next thing, we wanted to measure the determinants of that participation. What makes someone to participate in a certain irrigation decision? And why does he not want to participate, or why doesn't she want to participate in other activities? And then if you participate, we also wanted to ask yourself, what is the intensity of that participation? If you go to an irrigation committee meeting once a week instead of 4 times a week, obviously a person who goes 4 times a week, but the intensity of participation is greater than that one who goes once a week. So we wanted to manage those, to understand those dynamics that were happening there. So I'm trying to show you how we used all these cross-sectional data analysis methodologies, superimposed them into multiple in one paper, and how they complement each other. You can move from one analytical technique into another and into another. And as we move, the complexity and the storyline becomes complex and becomes much more informative to the reader. So the first starting point was to say, how did we conceptualize the issue of participation? So we conceptualize it this way, quantitatively. When we ask you to say, do you participate? You have to rank yourself. You are not participating at all. I'm not interested. I don't go there. When they call a meeting, I don't go there. And then there's someone who is not participating fully. He tells you, instead of attending meetings every month, I attend once, possibly in 4 months. But I do understand. I do participate at times. When I go there, I give ideas. And then somebody comes and say, participation as an ordinary member. I'm an ordinary member. I'm not a committee member. I'm just there. I go there, I attend everything. And then somebody says, I'm participating as a committee member, which means to say, as you become a committee member, you raise up your hand voluntarily, you're not paid to participate. Surely your level of participation is much more than an ordinary member who just comes there, sit, listens, and go home. Though you still need his vote or her vote. And then somebody who participates as a chairman or as a really decision maker within that system, which means the intensity of participation there is actually much more. And there were so many of these chairmen, because they were divided into some groups as well. So you can see that we have started conceptualizing the data into categories, trying to measure that level of participation. And after that, we had to run descriptive analysis of all the variables. We interviewed about 307 respondents. We ran the descriptive analysis. I'm not going to bore you with all these descriptives. I had to project them there so that you see that those are the processes that you need to do. So the descriptive analysis, it included average age, average number of household members, average number of years in formal education, because all these variables, we perceive them to be influential in determining how you are willing or not willing to participate. Your income levels, your average irrigation area. If you have a better hectarage, you might want to participate more because you want more water, all those variables. And we continued, we even grouped some of those variables into categorical data. Your gender, are you male, are you female? Training, have you received training in irrigation or not? Yes or no, with the assumption that those who received training might want to participate more than those who did not. Are you a member of a water association? Are you involved in conflict resolution? Maybe you're a member of a disciplinary committee, within the so all those sort of things. So I had to tabulate all those, and you can see the frequencies and the counts. But don't add these frequencies here, because if you add them up, they don't add up to 307. They just tell you the percentages of the respondents who actually answered in affirmative for each of the categories. And then thereafter, we had to say the level of participation of a farmer. We realized that there are about 5 dimensions that are involved there. Either you participate in terms of building canals, or you participate in terms of attending meetings, giving ideas, but you don't want to build canals, or you participate in terms of actually ensuring compliance. There are some people who tells you they are the ones who monitor compliance, who give penalties, who go into disciplinary enforcement of rules. We know that if you steal water, we report you to so and so. That's another dimension of participation. And we identified 15 variables that we measure in participation in different categories. And we ran all of them to reduce their dimensionality. And we end up coming up with 3 principal components or your factor loadings to say there are 3 main components that really affected, 3 broad categories that affected participation. After that, we wanted to say of these 3 broad categories, unfortunately, forgive me, I should have told you what component 1 means, what component 2 means, what component 3 means. In this case, I think component 1, if my memory serves me well, if I'm not mixing up the variables, the component 1 was those that really participated in the scheme through giving their labor, participation in canals and all that. And the second component was to do with participation in terms of meetings and all that. And then participation number 3 was to do with enforcement of rules. So those were the 3 broad categories. And these were the factor loadings that came in. And then thereafter, we wanted to say, what determines that participation? So we had to run regression against the factors that affect participation as membership, participation as attendance of meetings, and participation as enforcement. So we now went further and say, this one, we generated an index, and then it became now a dependent variable. This one became another second dependent variable. The third one became another third dependent variable. And then it became now continuous because it was an index. And because it was an index, we now ended up applying the top-bit regression because it's one index that now could take continuous data, and it was a censored one because your participation level can only range from 0 to 1. There was no way it goes beyond 1 or 100%, and there was no way it can go on the other side, negative. So it ranged between 0 and 1. And that 0 to 1, we actually realized that it was actually censored between a certain interval because it was an index that we constructed out of all the scales. So we applied the top bit. And after applying the top bit, we applied all the assumptions that were required. We tested for multicollinearity. We're using the variance inflation factors. We tested for normality and all that. And then this is what came out. When we ran the top bit using those descriptive statistics variables as factors affecting participation. This is just one of the regression results that came out. And then we realized that if you check on these ones with 1 star, 3 stars, these are all significant at different levels. 1 star at 10%, 2 stars at 5%, 3 stars at 10%. And then these are abbreviations of the variables that actually affect the level of participation, which is basically here, the position that a farmer is positioned along the block. It's a 20-kilometer scheme. Are you at the top? Are you at the middle? Are you at the low? You will find that those at the top are not willing to participate in most cases because they can get water anytime. Those that are at the bottom, they want to participate more because they're always in short supply of water. So I want you to see how we have managed to scale from defining qualitative variables. They've migrated into descriptive, into principal components, where we're constructing indexes from the same questionnaire, same data, and then we escalated it to a regression analysis. Now we want to see the determinants of those variables on some of these, on the actual participation into collective action processes. After that, we even said, okay, now these farmers are participating in. What is the intensity of that participation? When we measured the intensity of participation, we now applied another model, which is a probit model. And the probit model now tells you that what is the level of participation across the different groups. Remember I told you that the 0, 1, 2, 3, the categories, what is the level of participation of those that say, we are not really willing to participate, and those that are saying, we are willing to participate, but just as ordinary members, those that are saying we are serving as committees, those that are saying we are serving at actually at an enforcement level. So then we started measuring the marginal effects of those to say this group here, let's take for example, you would find that, let's say we want to interpret a variable like, let me check, the amount, let's say average amount. This is the amount of money that they make out of irrigation. The amount of money that they make out of irrigation, if you can look here, there was the amount of money that you receive after participating in irrigation activities was positively related to your level of participation. So there's a positive coefficient there. But to which group was significantly affected? Can you see that everyone who has money, the marginal effect here is actually also positive, and it's actually going up, except for this group here. This group here was actually saying there's a negative relationship between the amount of money that I have and my level of participation. It could be true because maybe the objective of this group here, who say we just want to participate with more ordinary members, they might be producing not for sale, but they are producing basically for home consumption. So money is not an issue to them. So it might actually not even, it's not an incentive for them to actually participate in an irrigation scheme. So at the end of the day, you will sign that, so the sign has to be interpreted and the level of significance has to be interpreted. So by now measuring this, and it's, remember, this is actually measured as the level of change that would have to happen for actually for us to be able to see any significant change, a significant effect on the level of participation. So basically, I've tried to demonstrate to see how you can cascade all the analysis and integrate them and be able to come up with one comprehensive paper or one comprehensive write-up, which starts as simple, but much more complex and applying multiple methodologies and multiple regression techniques, quantitative techniques to come up with solid answers. So I think after that, I can actually say when you're dealing with quantitative data, you must be aware that if we get all these results, it's not that these results can just come out. You must be able to know the weaknesses. You might experience limitations in terms of missing variables. You might experience in the sense that the data can be outdated. You can actually be experiencing problems of sampling bias and the source bias. So all those challenges, you must be able to address them when you are really collecting your data. And the right sampling techniques ensures the best data set. And the completeness of your data also ensures the best data set that you can have. So colleagues, I want to end here. And I hope, colleagues, I've just managed to browse through. There's so much that we can talk about, but I've just tried what I could to make sure we can open up the discussion on cross-sectional data analysis as an analytical tool and as a rich data source that we can use to enhance our research. Thank you very much. Over to you, Chair.
Thank you so much for a very informative session. We do have questions on our chat box, which I would like to take you through. The first question is from Ntombi Matoma, which says, can we say that pooled data is longitudinal data? Should I repeat the question?
If I hear you're saying, can we say that pooled data is longitudinal data?
Yes.
Yes, because it also includes time series data. The same as the longitudinal data can also be regarded as the panel data sets as well. You are collecting it over a long period of time.
Okay, thank you for that answer. I believe that our audience is answered on that. Okay, we do have another question from Dombi again, which says, how many tests can one run at PhD level to validate your data? For example, if you run a regression, what other further tests may be run?
I cannot specify to say you need to run so many tests because each regression model comes with its own post-estimation test. You can't prescribe because if you go back to the fundamentals of regression, even the type of assumptions that you run for each regression model, it differs. So the assumptions that you run to say, before I apply this, let's say you have read your literature and then you realize that OLS is the most suitable methodology for this type of data. it's interval data or it's scale data, and the dependent or the independent variables are categorical, continuous, and all that. Once you run your test analysis to determine whether it really suits the data, then each model prescribes what needs to be done, and you can't then do shortcuts, or you can't say at honors I can do this, and at PhD I can do that. If you are running a model, the model should be consistent whether you're running it at a master's level, PhD level, or honors level. It has to be done robustly, and you need to do all the post-estimation, post-estimation procedures that are required.
Okay, thank you for that answer. I don't think we do have any more questions from our chat box. So I'm going to request anyone from the audience who has any question they would like to ask Dr. Muchara before closing, they can just do that. I'm giving you the platform to come forth with your question. Okay, I can see a hand from Ida. You can unmute yourself and ask your question. Thank you.
Yes, thank you very much. And thank you for the really informative presentation. I had put something in the chat box, not a question, but it was a request. I was wondering if when Doctor is sharing the PowerPoint, if he can also share maybe an example of his code book, at least one code book that somebody can have a look at. If it's okay, that is.
Yes.
A humble request.
Yes, I think that's a fair request, and it's very possible. Unfortunately, because of time, I could have just opened an SPSS, but SPSS is heavy. At times it can freeze and kick us out. That's why I didn't share, but I can share any rough data set. And when you open that, but the challenge is if you don't have SPSS, you might not be able to open it. So I will share a code book in SPSS, and you should be able to have SPSS on your computer so that you can be able to open it. And then when you open it, you go on the data side and the data view. So the code book is on the data view side. I can be able to share that together with the PowerPoint presentation. Thank you.
Thank you so much, Dr. Muchara. Let me go through to my chat box. I think we do have another question. It says, it comes from Morocco. It says, how do you deal with the resistance mostly from qualitative data collection from the target population, mostly big companies that do not want to share information?
Yes, this is a challenge. And remember, we might call it resistance, yes, but in most cases in research, I think this is some of these respondents have really experienced research fatigue. You can imagine how many universities are offering postgraduate education in South Africa, just in South Africa. And all those candidates are going to companies to do research. And the other thing that actually causes this resistance, it's us researchers. We don't go back to go and give feedback on our findings to the respondents, to the companies. After we have collected our data, the most ethical issue is share your output with these companies so that they see value of our research. Once we start doing that, we are also paving way for the other colleagues who want to go and investigate further from where you left. But in the event that there is a resistance, unfortunately, there's nothing much that you can do. If you persuade and they say they don't want, there's nothing much that you can do. You have to move on and look for another organization. It's a hard answer to be told. It's a hard response to be told that I'm sorry, we cannot deal with you, or we cannot sign your ethics letter as consent. But I think as researchers, let's start giving back to the community. Let's go back and give feedback. Let's share our thesis with them. Let's prepare PowerPoint presentations into the management to tell them the outcomes and how it can impact their organizations. They will start opening that up because they are getting free consulting out there from the researchers. Thank you.
Thank you, Dr. Muchara. Another question is from Dumoyo, which says, I have read a lot of PhD theses, especially from UNISA. I noticed many students hardly do a preliminary analysis to understand their data. Is there any policy to ensure standardization of research quality?
Yes, we do encourage students to do, what can I say? I don't think it's easy for one to draft a specific policy that says we need to be able to do pre-analysis and all that. Because that is the prerogative of the researcher and the supervisor. So once you start seeing such research, we do not do pre-analysis or trying to do post-analysis. It's a weakness that could be emanating from the candidate himself. Maybe he's not strong from quantitative background and might require additional quantitative background, or did not do much thorough reading of literature of the methodology that the researcher has applied, or from the, maybe the supervisor as well overlooked such a weakness, which becomes problematic, because then how do you justify the significance of your outcomes if those pre-tests are not done? How do we then rely on your data set? Unfortunately, you would find those cracks, but there are numerous sources of such cracks. And I think it's us here who are researchers, we need to strive to make sure we eliminate such weaknesses and we bring out the best output in terms of all the research. Thank you.
Thank you, Doctor. From our chat box, I think that's all question that we have. If there is anyone from the audiences who would like to present their questions, I'm giving you the platform to please do so. Just unmute yourself and go straight to the question. Thank you. I'm not sure if Moroka Kautzani would like to say something, because I can see that they keep on unmuting and muting themselves. Okay, Dr. Muchara, thank you so much. I don't think we do have any more questions. Do you have anything to say, maybe any comment or anything that you'd like to say it or before we close the session?
No, thank you. I'm fine from my side. I want to thank the attendees for quite a good engagement. I think we can only do this to enhance our research and our research capacity. Thank you very much, Binganidzo.
Okay, I see that we do have something that just came into our chat box. I'm not sure if it's a question or, okay, I think it's a question, which comes from Okoye. It says the COVID-19 pandemic is changing the data collection approaches largely to online. How do I ensure high return rate of the tools? My current results have been disappointing despite many reminders to potential respondents to fill. So how do I then also be ensure such data will be authentic if it's based on a repeat nagging to request their respondents to participate?
Yes, I think this is, yes, we might blame it on COVID, but I think online data collection is always there. I think if you look at the historical, we used to email and all that. Now, because of the SurveyMonkey, online data methodologies, because of technology, most companies are collecting data online. And I think this is a challenge that that is here to stay. I think the culture of contributing to research as respondents is very low. And it's a dilemma that we really need to change in terms of how people can be interested in surveys. There are so many reasons for that research fatigue. There are some online surveys, I think you have received some anonymous and solicited calls and solicited emails. Some of them you can't distinguish whether they are phishing emails or they are junk mails or, you know, dubious phone calls. And because of that, there are some who do it for make money. There are some who do it for honest research, like us academics. Unfortunately, the consumer out there who is the respondent cannot distinguish between academic and non-academic research, cannot distinguish between a phishing email, a bogus, which a hacker, versus an email that is authentic until they open and read. But in most cases, some of these, they fall into the junk mail. The moment you receive it falls, it surfaces into the junk mail. But indeed, the problem is there. There is low response rate. For you to achieve maybe 100 questionnaires, you might even have circulated over 1,000 or 2,000 questionnaires. There is a very low respondents. It's a big challenge, but there are other alternative ways that you can actually try to collect data. One way of doing it is possibly to mine this data from social media platforms. If your design allows you to do that, most likely you get qualitative data. You can then code it into quantitative and try to come up with, but it has its weaknesses. You can't then say it's your data collection tools, but we might see ourselves gaining more momentum in mining data from online platforms and analyzing that data. So we might need to upskill our skills for data mining. But in terms of response rate, I'm sorry, I don't have a solution to this. It's something that it differs depending on the sector that you are targeting, the clientele that you are targeting, and it differs in terms of the type of research, the sensitivity, and all that. It's quite a complex question to be able to get one answer to be universally acceptable. Thank you.
Okay, thank you so much, Dr. Muchara. I'm now going to give Heidi Trollip a platform to say their question. Thank you.
Oh, thank you for the opportunity. I just want to add on to the question previously asked about the low response rate. It is a problematic at this moment, as Prof mentioned as well. The thing is, what can you do with a low response rate? At this stage, I spoke to my statistician, and I've got at the end of the day, say like 10 or 12% response rate. That's not a very high one. I'm now busy writing it up, and all what you can do sort of is like frequencies. For me, I will now ask my question. I have a mixed method study. So I know that I've got about 25 interviews and it will pull me through. But how credible will be that 38 complete surveys questionnaires that I receive? Because I can only do frequencies. So you can only describe. And I don't know, it feels boring to me. So my question is, how credible will it be, of what can you do to make it more credible, as only describe what the frequencies?
Yes.
Thank you.
It's difficult. If I showed you the stages that I took through to do my data analysis. When I was at descriptive statistics, I never took it as an analysis. I took it as a preliminary, the one that you use to collect, to clean your data, basically. Because you can't really make any inference from such data. It just shows you the distributions, the layout of the data. So you can't really do any inferential statistics with a sample of 25. Otherwise, you get spurious regressions. You end up accepting everything that was not supposed to be accepted, or rejecting everything, including those that could have been accepted. Your error type 1, type 2 errors. That's an extremely small sample for quantitative data. The most likely thing that might end up happening, yes, you can quantify quantitatively, but you might end up going more into qualitative, build up more on your qualitative type of data. Then you might even end up following up what has come out of those quantitative small survey to be able now to say, can I really get qualitative data to back up these small frequencies? But even those frequencies, some data sets, they're extremely slow that even percentages don't make a sense to say, can I really express data as a percentage? Just say 6 people responded and 4 said no, instead of saying 60% of a small sample, you know? So it's unfortunate. You might end up going qualitative and build up on more on your qualitative strength and do some more in-depth interviews to actually build up on your data.
Thank you so much. I hope, okay, you can go on, Heidi.
Sorry, I just want to say thank you. At one stage, I wanted to go to my supervisor and say, can we just focus on qualitative? Can I just change my study to qualitative because I've got good data there, and forgot about that I said in the beginning, I want to do a mixed method because this is like a nightmare for me. I didn't ask him yet. Will that be a solution? Or I was thinking at the end of the day to say, when I start writing it up, you mentioned it already, Prof, to maybe use it as a stepping stone. And yeah, no, this, I must say, this is a really difficult journey.
Is it a PhD?
If you don't get the response right.
Is it a PhD or a master's, or what level is your study?
It is a PhD
yes,
study.
but normally we say, I would always say, whatever you want to do with your data, don't do it alone. Go back to your supervisor, discuss the dilemma that you have, so that if there are any methodological changes that needs to be done to talk to your data, you do it as a team. It's your work, but you still need, you don't want your supervisor to be saying these are surprises. How did the design change when he sees the first draft of your results? You need to discuss those data issues now. There is the most important part, the most important thing, fundamental principle in research: declare everything honestly. If the data collection was a challenge, response rate was a challenge, and there's a weakness in your data, declare it up front and tell the examiner what did you do to make sure you mitigate the risks of unreliable data. Declare up front so that you are punching holes on the questions that the examiner could have asked. Tell the examiner your original intention. Tell the examiner what you got after that original intention. Tell how that intention changed after the dynamics within the data collection, and how you intended to, how you then redesigned your approaches to strengthen the final outcome, with all the scientific justification for each stage that you have done. And you need to do that with your supervisor, come up as a team, and then build that case to say, this is the way we moved forward. As researchers, we might also learn from your approach to say, this is how best you can handle, because it brought some scientific rigor in it. Thank you.
Thank you so much, Prof. Thank you.
Okay, thank you so much, Dr. Muchara. I don't know if there's anyone else from the audience who would like to say something, maybe a comment or a question. You can take the platform.
And I see there is one question that came in the chat box. which says, what of using non-parametric statistics for small sample size under 30 observations? My assumption is a small size fails normality test. Yes, that's correct. As most small sample sizes do fail the normality test. And once it fails the normality test, you end up running your non-parametric test, which does not want which do not really talk to the requirements to meet the normality, your normal distribution. So that's one way of looking at it, but still it depends on the type of data. I wouldn't want to prescribe to say you can use that and that is normality test, non-parametric, but go and read the non-parametrics, check the assumptions, check your type of data, and see which of the non-parametrics, and I think I gave all those examples, your chi-square, your man-Whitney test, your score, all those, just to go and check which one might talk to your specific data and what is the intended outcome that you want out of that. It's also a very good approach to resolve the issues of small sample sizes.
Okay, and I see there was another one under that it says at PhD level, is there a possibility of only doing quantitative-based research with total satisfaction?
I'm not sure what that means, total satisfaction. I might have to interpret it. I'm not sure what that colleague wants to say. Whether he's trying to say, can you only do quantitative data and be able to pass a PhD without backing it up with qualitative? Is to say, can you meet the requirements of a PhD with just quantitative without qualitative? Yes, you can. There are really other PhDs which are purely quantitative in nature, relying on time series, panel data, and all that. You can be able to meet the requirements of a PhD with just qualitative, depending on which field you're coming from. Most data from economics, there are some economists who don't even do surveys. They just rely on historical data, secondary data, World Bank data, over 100 years, 50 years, and all that. So you can. If I interpreted your question correctly, unless I misinterpreted your question, you might want to raise your hand or clarify the question. Okay?
Yes, I'm going to give him the platform. I'm going to give him the platform to tell us if it's been answered or not.
Hello?
Yes, we can hear you.
Oh, great, that is good. There's a lot of rain here, so I was having challenges. Doctor, you have answered me well. I'm happy because I was just looking at it. I thought maybe largely you'd fear or you'd not get that requirements when you only go quantitative. Because the challenge normally is we are not sure of the data which people give us. So sometimes there's that urge you have to go out to the field to verify that information so that you are sure by the time you make your presentation, you are defending it, you are sure it is actually what you found out in the field.
It's correct. It's correct.
Thank you.
But remember, Patrick, the type of quantitative data that you have, it varies. There are quantitative data that you have that have been collected with tested methodologies, and you normally get the secondary data, panel data. They've been going on for years. And then there is the quantitative data that I was demonstrating, the cross-sectional data. And it's collected on a 1.1 time. And the is 100% correct. That's why now it makes more sense to follow up, because most of the responses that you get, yes, you can get hardcore data, but most of those surveys, in most cases, they are perceptions. They measure the intuition based on the respondent at that specific time. So you would want now to follow up with interviews, focus groups, to validate what you would have come out of the quantitative data. It's a good practice. But where such opportunities does not really avail itself, maybe because of resources, because of time, you can also try to make sure you validate those outcomes, maybe in literature, back it up, the arguments, whether it's consistent or not consistent. That's my input.
I'm very happy.
Okay, thank you so much. Thank you so much for that feedback. And thank you so much, Dr. Muchara. I can see that our time has already. Okay, sorry about that. I'm having network difficulties. I just wanted to say thank you so much, Dr. Muchara. And I'd like to thank our audience as well. This was a very insightful session. And before we go, let me check our chat box if there's anything else. Okay, there's a comment from Heidi which says, thank you again. It was very insightful. Thank you. I would like to say we really enjoyed your presence, your presentation, the way you conducted it. It was very insightful. And we do have another session which is coming up on the 28th of October. I would like to urge everyone to please avail themselves for our next session, which is on the 28th of October. And also, please do follow us for more information and recordings on our social media platforms. We do post the recordings of the sessions on our social media platforms. And also we do inform our audience of the next sessions that we're going to host on our social media platforms as well. So I would like. Okay, sorry about that. My network is very bad. So I'm going to thank everyone for being here.
Thank you. Okay, I think colleagues, with that, she wasn't hearing that I was taking over. Colleagues, thank you so much. Hope to see you on our next session. Thank you and have a beautiful afternoon. Thank you so much. Bye.
Thank you.
Thank you and bye-bye.